Hi, I'm Bob from Hauptwerk Hardware, and we're having a bit of a heat wave here in the UK this week, so I've had to trim the beard back a little bit, but hopefully still recognisable to all of you who've been following this series. So in this video today we're going to take a look at this. It's the Hauptwerk Hardware System 1 Motorised Stop Interface, and it takes up to 24 motorised draw stops or tab stops. But not just that, we're going to take a look at this as well, which is exactly the same thing but for 48 draw stops or tab stops. So let's get these onto the bench and take a closer look and see what we can do with them. I've got this motorised stop interface on the bench now, along with a few other things. So we've got a Kimber Allen draw stop here. We've got the System 1 control board over here. And then I've got a small Cat5 Ethernet type cable, which we're going to use to connect the stop interface, motorised stop interface, to the control board. The control board's connected to the computer via this USB lead here. This is monitoring the control serial output. So if we take a quick look at the computer screen, you can see here I've got this open in PuTTY. And that's just showing what it sent when we powered the thing up. So it just says that the controller's ready, and it sent a note on and a note off, and those are basically those events there are just part of the power management system, so it'll always send those, but that's not relevant to what we're doing today. And then behind that I've got MIDI aux running, and that is monitoring the MIDI, which is coming from this port here through a Turtle Beach MIDI interface, USB to 5-pin DIN MIDI interface. So that's what we've got going on. So we've got this connection here. This is just a little connector I made up. This plug matches up with the plugs on the back of the new or the newer type Kimber Allen draw stops, and that just plugs in there. So that makes them nice and easy to connect to, and these little plug things are quite good actually, because you've just got these little tiny orange things. If you push that in, that releases the tension on the wire. So if I push that in with my nail, now that wire can easily just be removed, and likewise for putting the wires in, you just hold that down, push the wire in the hole and release, and then that's the connection made. And the other end of the wires, I've tinned those ready so that we can easily solder those onto this motorised stop interface. So that's what that bit's about. And then let's just move that out of the way because we don't really need to see that. I've got this diagram, which is printed out from the Motorised Stop Interface user manual. I'm not certain what page this is on, but obviously you'll find it if you have a look in the user manual, which you can download. It's free and everything, obviously, from the downloads page of the website, from the Hauptwerk Hardware website, and I'll leave a link to that in the description below. But we can refer to this as we go through so that we can see what we're doing. So those are the bits and pieces that we've got to work with here, but before we start, let's just take a slightly closer look at the board. Okay, so here's the board, camera zoomed in. Hopefully we can read all of the legends on the board and everything, but if we just work our way around so that we can see what the different connections do. So let's start here. So this is just an ordinary RJ45 socket, which accepts the Cat5 Ethernet type cable, which we looked at just now, and that's where, as it says at the top, two system boards. So we plug one end of the cable in here, and the other end of the cable we plug into this socket on the control board where it says motorised stops. So that's nice and easy. The next socket down says from next board, so you can daisy chain these. So this is a 24 stop board, so obviously it does 24 draw stops. However, there is a bigger one, its big brother, which is this one, and this does 48. So to get the whole thing in shot I'd need to zoom the camera further out, but it's exactly the same. It's just bigger and it has more of these connectors around the side for connecting stops to. So obviously this one does stops 1 through 24 along the bottom, and then 25 25 there through to 48 along the top, and you can daisy chain these together. So as I said, if we get the two boards in shot together, then the way that would work is that we would take our lead from this board where it says to system board, and we would plug the other end of that into here where it says from next board, and then obviously you'd have another one of these cables, these Cat5 cables, coming from here into the control board. So that's nice and easy. We can just daisy chain those together, and you can have up to a maximum of 120 motorized draw stops on one system. And the way that they'd be numbered would depend on how you daisy chain them together. So we always start with this socket here to system board, and then we've got stop 1 would be here, and then we go right through to stop 24. So when we come from the next board, the first stop on the next board would be 25, and then that would go on to either 48 or 96, or however many you've got, dependent on how many stops the next board can handle, and so on, up to a maximum, say, of 120. So that's how the daisy chaining works and the numbering works. Now, moving around the board then, we've got two connections here, VCC and ground. So this is powered from the main control board. So the power comes down the this Cat5 cable that we're using and into this board. But if you need to make sure the power's getting there, if you've got any problems that you need to be testing or anything like that, firstly we've got a little LED here which lights up to show that there's power on the board when it's connected. But also, if you weren't certain, maybe you thought the power was a bit low or whatever, you can measure it between these 2 points here, and there should be 5 volts between those 2 points. The next connector, solder pad, is this bigger one here which says stops positive. Now this one is really important, because if we look at our little diagram here as per the manual, our voltage from the stops power supply, that must go to that stops positive solder pad, this one here. And even if you're powering the stops directly from the power supply rather than through the let's get this back in shot, rather than through here, then you still need to have that. So one way of doing this is to have your power supply, stops power supply, positive connected to here, and then that is relayed round to all of these connections here where it says plus V. Okay, so that plus V is connected to this stops positive, so that's why it's a bigger solder pad, and this is the safest way of doing it. You can take a heavy duty wire from your stops power supply, and then you can connect a smaller wire from plus V to each stop. So each set of 4 of these little solder pads is one stop. So because it's only driving one stop, you can use thinner wires. If you go this route and you have this power output from your power supply and you just connect this directly to the stops, then you need to use a much heavier gauge wire, and you also need to have some sort of wire connected back to this stops positive on this board here. The reason this must always be powered is because it provides protection to or for all of the switching chips on this board, which actually turn the power on and off to these coils. And I did a video a bit further back, which you can go and find, which explains what happens within these coils and why we need this protection and why we have to have this connection. But basically, leave it out at your peril, because if you forget to connect this, then the first time you operate a stop through this, it will destroy the chip. So this is really important that you have that connection. So that's that bit. Now, as I just said, this one does 24 stops, and therefore it's got 24 of these little sets of 4, and each set of 4 is the same. You've got a plus volt connection, so that is, just move all of this into shot at the same time, there we go. So this plus volt connection is the one that would go to both of these coils, to the common side of both of these coils. And when you look at how these stops are actually wired up, there is one connection, which is that one on the Kimbrell and stops, the middle one here, that goes to one side of both of the coils, and then these other two are the other side of both of these, or of each coil. So putting power onto here and then making one of these or the other of these connect to ground will cause the stop either to move into the on position or to the off position. And then these top two connections on the stop here are for the reed switch, which is this here over in our little drawing. So our little connector that plugs into the back of that stop, the way I've wired this up just for demonstration is that the top one, this wire here, that's coming from one side of the reed switch. The next one down, which is tricky to get them all in shot, the next one down is actually connected to the common for the two coils. So this connection here is connected to this connection here. So in other words, if we connect this to plus volts, it's going to supply power to one side of the reed switch, and it's going to supply power to one side of both of these coils. So that's why those two are connected together. So we will connect that to our plus V connection for the stops. And then obviously this one that we looked at just now, which is this top one, which is marked as reed 1, that will connect to the SW or switch input solder pad. So that's as per this little bit of the drawing. And then we've got these two left over. One is for the on coil and one is for the off coil, and so obviously we'll connect one to the off pad like that, and we'll connect the other one to the on pad like that. So that's what I'm going to do now. So a quick pause in the video whilst I connect those together, and we'll carry on and see how this works and what MIDI we get from it and so on and so forth. I've connected the stops board now to my small power supply there, so that's supplying 15 volts DC into here. So I'm just using this ground connection here, and this is the stops plus power supply connection here. So as I say, it's 15 volts DC on here between these two, and then I've soldered these wires to the stop on here as we just discussed. So the plus volts, so that's 15 volts coming in here, plus volts is coming to these two wires, which on our little diagram is that plus volts there, which comes to one side of the reed switch, and the other wire is this one here, which goes to these two coils. So that's what these two wires are, and then we've got this wire here which goes to the SW connection. So that's this one, so that's the other side of the reed switch. And then we've got finally these two wires here, which are to this side of the coils. So one for the on coil, one for the off coil, and these are connected here, obviously one to the off solder pad and one to the on solder pad. So that's how the wiring works. Then we've got this plugged in using our little Cat 5 cable. We've got it plugged into the controller, and this is plugged into the socket labelled Motorized stops. And this is plugged into the socket, as you can probably see there. Not certain whether it's clear on the camera, but it says to system board. So that's all of our hardware, all of our power supplies connected. So if we have a look at the computer now, you can see we've still got this same display here, which we get when the control board is powered up. So if I go back now and I pull this draw stop out, you can see two things have happened. Firstly, it said on this comms session here that is sent note on 23 on channel 7. So all of the motorized stops operation in system 1 happens on channel 7. So this is sent note on 23, and that's from this stop here, which is labelled 24. The reason it's note 23 is simply because this monitor starts at 0 rather than 1. So this will be stop 0, stop 1, stop 2 and so on. But in terms of what it actually says in the MIDI output, that's going to be number 1 through to 127. 1 through 127. So that's what that's all about. So if I press this back in now, you can see that it's sent note off, channel 7, note 23. So when the stop's pulled, it sends a note on, and it doesn't do anything else until you push the stop back in when it sends a note off. So that's nice and easy to use with Hauptwerk, Grand Organ and all of those other virtual pipe organ type softwares. Now also just on the computer here you can see that it sent the note off when I push the stop back in. So that's the matching note off for that number 23 on channel 7. So that's that side of it. What I'm going to do now is going to send some MIDI to this from the computer to make the stop operate. So if we remember from what it says on here, it's note on 23 channel 7. What I'm going to do is just close down this MIDI aux, and I'm going to open up a different MIDI program. This one is Pocket MIDI, and it allows us to send MIDI out, and that comes from this little keyboard here. So we want to be right down the bottom end of the keyboard. We want to be on channel 8, I think it is, because again it's that 0 and 1 thing, so it gets a bit confusing, to be honest. But what should happen now if I'm on the right channel, which is fairly easy to find out, because if I pull the stop again, you can see in the MIDI in monitor here it's come up with the numerical representation of that stop, and when I push it back in, obviously it shows us that stop being switched off. So 7F, that's the velocity when it was switched on, 0 is the velocity when it was switched off, 17 is the hexadecimal representation of note 23. So if I now send where are we, 23, which should be, what's that, 12, 13, 24, so it should be 23, so it should be that one. As we can see, the stop turns on. So it sent that. If I let go, it will turn off, because it sent a note on here, so the note is 17 in hexadecimal. I don't know, actually, can we tell this to, it would be easier if we can view it in ordinary decimal rather than hex. I don't see an option for that. So no, but anyway, 17 is 23, or yeah, it would be. So as long as that note there matches this note here, then that should be fine. And 97, 7 is the channel, 9 is the command for note on, 8 is the command for note off. So that's how that all works, but really you don't need to care about any of that stuff. That's just delving too deep really into how it actually works, because once you set up Hauptwerk or whatever to work with this, you can just do auto detect. You don't need to know any of these numbers, you don't need to know what channel it's on or anything else. It's really, really simple, and we'll have a look at that a little bit later on, how that works as well. But just suffice to say that I can go to here, and when I send a note on, the stop pops out, and when I send a note off, it pops back in again. So that's basically how that works. Obviously all of the other stops will work in the same way, just with different numbers. So what I'm going to do now, just because we can really, is I'm going to grab that other 48 stop interface, and I'm going to plug that in between these two. So what's going to happen then is that instead of this being stop 24, it's going to be stop 48 plus 24, which is 72, and because of the -101 thing, it's probably going to be 71. So give me a second to set that up, and we'll take a look at how that works. So what I've done now, as I say, just plugged this into this 48 stop board, which I can't really get in the camera view very easily, but there it is. You can see it's just the big brother of this one that we looked at earlier, and then the other side of this comes out and into the Motorized stops connector on the main board. So now if we everything else is the same, if we pull this stop now and we look at the computer, we can see that instead of having note 23 or 17 as it was in hex, we've now got 47. And that is because, although it's the same stop on the same board, it's now plugged in through this board, which has 48 stops on it. Okay, so that's how this works. Stop number 1, which will be this one, no it wouldn't, sorry, it's down the other end, but stop number 1 on this big 48 board would now be our stop number 1 as far as MIDI is concerned. And stop number 48 on this board obviously would be the last one on this board, and then 49 would be the first one on this board, and right up to 72, which is this one. And that's what we can see on the screen here. Unfortunately, it's in hexadecimal, so it makes it even more complicated and makes what I've just said sound really difficult, but it isn't. Basically what we're saying is that stop number 1, whichever board is plugged in closest to, on this daisy chain, closest to the controller, that's going to be stop number 1. If I did it the other way round and put this board in first, so this will be 1 to 24, and then the first stop on this big board will be 25. So hopefully that makes sense. So coming back to the computer, say that's 47. Obviously if I do the same thing and send a note 47, which is not that one, where are we, that one, to this, that turns it on when I send the note on, and it goes off when I send the note off, or when I release the key. So that's how the numbering works. I think I've probably just made it sound really complicated, but hopefully it's really not that hard, and it's all explained in the manual. Anyway, so what I'm going to do next is, that's a quick overview of how this works. We can see just using our test bits and pieces here. I'm now going to show you a couple of stop jams which I've just wired up sort of quickly to show how this can work with obviously more than one stop. And what I've actually done, one of them is wired up all nice and neatly, and I've actually used the existing wiring that was to the stops in the donor organ where this came from, and the other one I've just wired up in a kind of easy to understand and quick way, and that really doesn't look too bad either. So it's just to show how easy this is to use, and also why you would want to use maybe 2 of the 24 stop boards as opposed to just a single 48 stop board. So let me get all this out of the way, and we'll have a look at that now. Okay, so what I've done now is got these 2 stop jams. Obviously they're reverse way round at the moment, but they're connected together. The 2 stop controllers or stop interfaces are connected together with a short RJ45, and then there's a longer one which runs all the way over here and down to our controller as before. And you'll have to pardon the noise of the fans, but it's connected up to this somewhat larger power supply this time, which is a bit of a beast and makes a lot of noise, so hopefully you can hear us okay above the noise of that thing. Other than that, it's connected back to the computer. So at the moment we've got nothing on the computer, and obviously if I pull one of the stops on here, you can see that goes on and off on the computer, and we can control it from the computer back to here. We'll have a look at that in just a minute. But before we do, let's just take a look at these 2 sets of stops. So this set here, what I've actually done is all the original wiring, which was all nicely laced together, and some of it that wasn't, I've kind of kept all of that, brought that round, and then hopefully you can see how that's just soldered to these connections on here, and likewise it's hard to see, but down in the other side there is the same thing. And then I've just mounted the controller on a piece of wood here, which is mounted to the front of the stop jam with a couple of screws. So that's nice and easy to do. And then the actual power for the stops, these are 24 volt ones, the power for the stops comes through here, which are these big red wires. There's a fuse in the middle, which is always a good idea when you've got a lot of these stops, because they can take a lot of current when you do a general cancel or something and they all operate together. So those come down to these big connectors here, these are Anderson connectors, and again heavy gauge wire, and then I've got this heavy gauge wire which runs all the way back, as we saw just now, to that power supply over there. So that's how that side works. Now this side was just a kind of quick, let's put this together as easily as possible, and you can see how that's been done. So all I've done is I've used these wires which I've soldered to these stops, and then without any kind of real cable management or anything, just brought them across and soldered them onto these solder pads here, but because the board has been put so close to these, and these are quite short wires, it doesn't actually look too bad. Everything tucks in there out of the way, and it all works perfectly. Again, we've got a fuse here with our two thick cables which come back down to the bottom to one of these Anderson connectors, which connects simply across to this one for the supply voltage for the stops. So that's really just to show two ways that you can do this to achieve the same result. One way is the nice and tidy way, and if we were wiring this from scratch, you would expect to spend quite a lot of time and patience doing this. And then this way, really, you know, it's kind of half an hour's work, just whack these wires across and make it work quickly, which you wouldn't really want to do if you were building an organ. Hopefully we'd be taking a bit more care and pride in it, but there we are. That's what we've done here. So I'm going to turn these two stop jams around now so we can see the front of them. They were from an old Norwich organ. The stops are very old. I think one or two of them are kind of only work when they feel like it as well, but it gives us an idea of what we can do with the controller, which is the main thing. So one moment whilst I turn these around. Okay, so that's what the front of these looks like, and it's a bit short on space here, and the cables aren't really long enough to lay these out nicely, but what I think I'll do is I'll just pop this camera on the tripod so that we can get a view of these stops, and then we'll go and look at the computer and we can see what happens when we can control them from the computer. But for the time being, they're actually connected to the computer at the moment, so if I operate some of them and we look at the computer, you'll see the note on, note offs happening as I'm operating these stops. Okay, so clearly that works, but we'll have a look in a minute and see the thing working the other way around. And in fact, I wonder if I can just pop this camera here for a moment. It's not ideal, but I haven't got a tripod mount on this particular camera. There we go. So you can see that lot and you can see the others next to it. So if I go over to the computer and just operate, you can see as I run down the keyboard those stops operating. So that's basically how it works. As I said, there's a couple of stops, those two that got stuck out. These are very old. In fact, that one's bent. So they're not ideal. But anyway, that gives us a good clue as to how that works. So that's about all there is to say really about these motorized stop interface cards. The length of cable that you can use between the actual interface and the controller unit, it will work up to about 3 meters. But normally if you are, well, you need to have a very big console is all I can say really to need a 3 meter lead between the stop jams and the controller. And all in all, by the time you've got the daisy chain put together, if you're using 2 or 3 of these, you wouldn't really want to exceed much past 4 meters anyway by the time you've added up the lengths between all the boards and back to the controller. It has been tested up to 7 meters and it does work, but I wouldn't recommend it because I think that's probably about the limit of what you can do with it. But as I say, 7 meters is extreme. So hopefully this has been helpful. That little demonstration I showed you just now with the 2 stop jams, that's where I was referring to you may want to use 2 of the 24 interfaces as I've done there rather than one 48 interface, because if you imagine those 2 stop jams mounted in your console and then this mounted in the middle or something, so you've then got 24 going off to one stop jam, 24 going off to the other, it's all very limiting in terms of what you can do with it physically. So by putting them, these smaller boards actually in the stop jams, you can just unplug these, unplug the power, and the stop jams then removable as one unit. It's also testable as one unit because you've still got all the electronics with it. Whereas if you stick this in the middle of the organ behind the keyboards or something like that, and then you wire this all across to your stop jams, if you need to remove a stop jam to replace a stop or for any other type of maintenance, it's going to be much more difficult doing it this way. So that's why I would sort of recommend using the smaller ones. Obviously, if you only have one large stop jam, or they're along the top of the keyboard, or some different arrangement, perhaps as you would have in a theatre organ where you've got the kind of horseshoe thing, then yeah, it would probably be a good idea to use one or two of these, because you're not going to be able to remove those stops in sections as you would in two stop jams. So that's the idea of the two different sizes and the whole design concept, really. But there we are, that's how you use it, that's what it does. I hope that's helpful. I'll put a link to the manual, the user manual, in the description below this video, as well as links to the other System 1 bits and pieces, as I have done in all the other System 1 videos so far. So thanks for watching, and I'll see you in the next video. Okay, not so fast, not so fast. Not the end of the video just yet, because we want to look at how this works with Hauptwerk. So if we take a look at the computer screen, I'm just going to start up Hauptwerk. This is the old version 4, used to be the free version. I don't think you can get this anymore. I don't use the newer paid versions at all, because this is just fine for testing. So we go with the free edition and click continue, and then we go to general settings and MIDI ports, and we've got our Turtle Beach MIDI USB to MIDI interface, which is what I'm using to connect between the DIN MIDI on the back of our control board here and the computer. So we need that ticked as console MIDI in, and then if we click the MIDI out ports as well at the top there, we need this selected, the Turtle Beach interface selected as console MIDI out as well. That's so that we can send the signals from Hauptwerk to control our motorized stops. So if we OK that and we load an organ, in this case the St Anne's Moseley organ, the one that comes with Hauptwerk, because it's nice and simple and it's just right for showing what we want to do. I've got this big power supply running still, by the way, so excuse the noise of the fans. Sadly there's not too much I can do about that, but anyway, there it is. So how do we use these mechanical stops, or these motorized stops, with our motorized stop interface and System 1 and Hauptwerk? Well, I've brought this stop jam over from the other part of the bench and got it laid on its side here, as you can see. It's far from ideal because it's kind of laying back at an angle like that. So to pop these stops out is going to take quite a lot more power than to push them in, if you see what I mean, because you've got to push them uphill. So this is really not ideal, but it'll do just to demonstrate. So I've got the control board, the motorized stop controller, or sorry, motorized stops interface 24, that's connected back to the control board just like we did before. We've got the big power supply running, we've got these big leads connected through to this socket down here, which is the power for the actual stops, and we've got our USB connected up to the computer, as we've just seen. So all we really need to do, if we want to set these stops up, is I'm not going to do loads of them. We'll just do these top three because they're easy to see. So let's say that we will use those for, on the screen here, let's just look at these pedal stops. So we've got the trombone 16 there, we've got a 15th 4, and we've got an octave 8. So let's use those. So all we need to do is right click the one that we want to do first, and click on Auto Detect MIDI Trigger Settings, and then we just pull our stop out and then we push it back in, and we can see now that this is all ready to go. It's found straight away that it's come from our MIDI output, our MIDI import, which is the Turtle Beach USB, and because we've got send matching MIDI output to control the draw stop, it's automatically selected the Turtle Beach as the output as well. So all we need to do is click done on that. So now if we pull this stop, you'll see that it moves on the screen, and if we push it back in, obviously it goes back in. But we can do it the other way around. If we turn this on the screen, as you see, that stop pops out, and when we turn it back off, it pops back in again. And it really is as simple as that. So if we do the next one, we just do auto detect again, and we pull the second stop, and then we push it back in, and then we click done. And now if we click on that, you'll see the second stop pops out and back in, and equally obviously if I pull that will work. And we can do the third one as well, auto detect, pull the stop, push the stop, click done, and that just works. And obviously we can turn the others on as well, and if we want to turn them all off, we can just click general cancel and they all pop in at once. So all of the explanations that I gave earlier about all of the numbers and the hexadecimal and all of that kind of thing, that really was just for those that are interested in how this works under the hood, as it were. In terms of actually using it, it's just as simple as I've shown there. So if you had, I don't know how many stops are on this organ, but how, you can see it's not that many. We've done 3 of them. It's taken just seconds. We can do some more. Let's do that one, for example. Let's use, I don't know, this stop over here. So we pull it out, we push it in, we click done, and then that now works as well. And obviously we can put all the others out, and when we click cancel, everything goes off. So it's that simple. To set all this up isn't going to take forever. It's really easy. So now it really is the end of the video. Thanks for watching. I hope that was helpful, and I'll see you in the next video.